Welcome back. In the past, we've analyzed graphs of functions. Today, we're going to identify, graph, and describe parent functions and also their transformations. So we're going to quickly just give a brief overview of some vocabulary. Parent function is any function without a transformation. Constant, we'll see what constant, zero, all these functions, we'll see what those how they appear and what they do. Finally, transformations are shifts, stretches, shrinks to graphs, okay? The vocabulary for that is translation, means to shift. Reflection, obviously that one is reflect. Dilation, this would be a stretch or a shrink. And those are going to be the transformations we're looking at today. First, constant function, that is something that is flat. It'll be y equals some number or f of x equals some number. Identity function is also known as linear. Okay, I'm going to go through these kind of quickly, so if you need to pause the video, you can. Quadratic function is here. We also think of this as being a parabola. And finally, a cubic function is an S-curve. We have a square root function. It kind of just juts out, typically to the right, unless it has a reflection. We have reciprocal function. This is also known as a rational function. And a lot of people call it rational because of the ratio. It looks like a ratio, a fraction. But a reciprocal function is any function with x in the denominator. Absolute value, it looks like a v. This is for distance, defines distance. It's always positive. We've seen, oops, sorry, I went the wrong way. And now the greatest integer. This one's probably the trickiest. It looks like a stair step, or some people just call it a step function. You might hear me call it a stair step because that's what it looks like. Here's what it does. It takes any value and it makes it to the greatest integer that it's already accompanied. So, for example, 0.25, the greatest integer that it's crossed is 0. So 0.25, if you put it in these double brackets like this, would actually equal 0. So what it does is it basically just cuts off any decimal point. The way we'll type this in the calculator is just do int, and then you type in 0.25, and I believe that would give you 0. Let me flip over and try. So if we typed in int, and then use parentheses and say like 0.25 or any decimal for that matter, it cuts off the decimal, yep, and it gives you 0. So that's how you do it in the calculator. All right, so let's use this. It says here, describe the following characteristics of the graph of the parent function, f of x equals 1 over x. Now remember, this is a reciprocal function, so that's its name. It's a reciprocal function. It says first, find the domain. The domain, that means we ask ourselves the question, how far to the left, how far to the right? Now I'm looking at this picture and there's a break here. There's an infinite separation between these two. That's an asymptote, and it's an infinite discontinuity, as we've learned earlier in the year. So I'm going to highlight that infinite break by drawing that line there, and we'll see there's another break this way as well. So the domain, if we ask ourselves how far to the left, we first need to look how far to the left does this piece travel, and it would go on to negative infinity. How far to the right does that piece travel? It looks like it's broken at the line x equals 0. So it would travel until x equals 0. Now we do not touch an asymptote, we just approach it. Because of that, I'm going to put a parenthesis. A u means there's a second piece after the break. It starts also at 0 and travels on to positive infinity. Now remember, domain is x value, so those are x values I'm referring to. I do have to break it here because 0 is not included. If 0 is included, I could just say from negative infinity to positive infinity. Now, as far as that's interval notation, in set builder, you could write it as just saying that x cannot equal 0 as long as x is an element of the reals. So you could write it this way. It's saying like x is basically all reals except it does not include 0. As for the range, how low does this graph travel? Well, it goes down to negative infinity. And then it goes all the way up until 0. And again, we have that break this time at y equals 0. So I could write it that way with the u, and it picks back up at 0, and it goes up to positive infinity. So the domain range on this one happened to be the same. We would just say that y does not equal 0 as long as y is an element of the reals. All right, so the first asks for domain and range. It asks for intercepts. As you look at this graph, does it cross the y-axis? No, it does not. Does it cross the x-axis? It does not, so there's no intercepts. All right, symmetry. If we can, as you see, it has symmetry about the origin. It does not have symmetry over the y-axis nor the x-axis, but it does over the origin. If you flip it both, over the y, then over the x, we do have origin. So we have symmetry about the origin. I know that looks like an N there. I'll fix it here in a second. As for the continuity, we've already talked about, and there is an infinite discontinuity. Here on this break. So continuity, we talk off the x values. It has an infinite discontinuity when x equals 0. So put that at x equals 0. We have to define the in behavior. Now, in behavior means limits. In behavior specifically is referring to when x goes to the left. We want to know what does f of x equal. And as this graph goes to the left, it's approaching this horizontal asymptote of 0. So the answer here would be 0. And the same is true when we go to the right. The limit as x approaches the right of the function is also 0. As we go to the right, this graph flattens out on 0. Okay? And finally, intervals on which the graph is increasing or decreasing. On the left, it looks like it's decreasing. On the right, it's also decreasing. So it's decreasing on the domain. So you could say decreasing over the entire domain, or you could just list out what the domain is. Again, it was x does not equal 0, xer. I think that's the easier way of writing it this time. Now you try this next one.